the homework was to take what I put in Discord. The homework was to take what I put into Discord and create a asteroid object. An asteroid object from you loosely basing it on what we put in we'd done in the tutorials. Yeah, so we'd got tutorial 5, which was all shapes that allowed us to draw any kind of shape. Now I think I've got this to work now. Hang on, let's just see if I've got it working. Is it gonna do it? There we go. So we got to that point where we could create any type of shape. And so we're trying to recreate the asteroids game, yeah? So the homework was to set was to create an object that will handle the asteroids. All right? So I have already done that. So I'm going to cheat. I'm going to go do my Blue Peter moment and say this is what I've created earlier. Right? So let me just do this. Yeah, here is one I made earlier. Right, so I am just blanking out that. Alright, so I'm going to explain what I did now. So first things first, right? I separated all the classes out. Yeah, I separated all the classes out. So the very first class that we wrote was point. So now it's in its own file. It's in its own point CPP file. And it's an exact replica of what we did. All I've done is separated it out. So this is the point class. And then I separated out the line class. Right? And the line class is a... is just basically the code I've lifted out from that big long file that we did. And I did it for everything. So we did line, there's rectangle. So it's got everything in it. Still got the same thing. And then shape. Yeah. So I've just taken everything out because I wanted to start coding this properly. Yeah. And so asteroid. Let's get rid of that. Asteroid, right? So people were having trouble trying to think how to create the asteroid from what we've got already. Yeah. So this is how I did it. Oh, crap. I've just noticed the bot's still. Let's do that. There we go. There we go. Just get random. Let's do a random color. Right. So you have and I did give a hint of this in the Discord channel because when people were getting frustrated because they couldn't figure out how to get started. I think some people got started but then couldn't figure out how to tweak it. So I gave a hint saying you need to inherit the shape class, right? Because the shape class does every shape, yeah? It does every shape, yeah? And we went and said that we want an asteroid that can be any shape, yeah? So start with the shape. And so I inherited the shape, and then I created some new private variables that are relating just to the asteroid. So there's the delta x velocity and the delta y velocity. So that's the direction, yeah? So that's the direction. So dxv and dyv is the direction of x and direction of y. So that's going to tell, that stores which direction we're going. And then we've got Vx and Vy, which is the velocity of the asteroid. This is the velocity in two-dimensional space where we're going to go, right? So you've always got to think of that, right? Is the asteroids move, right? So, get me out on straight. The asteroids move. So they need a figure to say on the x-axis, how fast am I going? And also they need a thing to say on the x-axis, am I going left or right? And same with the y-axis, how fast am I going? And then a direction that says, am I going up or down? All right? Then this is where people were getting a bit frustrated, because they were trying to figure out how to make a asteroid jagged. So I will get into that in a little bit. First, I want to get over the concept first, and then we'll go into the bits. Yeah. So I've got a couple more private variables. So this one is to do with the jaggedness of the asteroid, how misshapen it is, and this is to draw the asteroid. Yeah, because I've changed the way the draw works. Yeah. I've changed the way it works. I've also overloaded the get X and get Y because of the jaggedness, right? And we'll get into that in a minute, because I will explain. Hey Proton, I will explain why I overloaded get X and get Y, because get X and get Y basically gives me the point on the circle circumference of the radius, but I don't want to do that. I want to get a point along its radius, to give the impression of a jagged asteroid, and I will go into that in a bit. So the constructor, well, the constructor is something going to be that's unique to the asteroid, right? So the constructor is saying where in the two-dimensional space am I being placed, so x and y. How big the asteroid is, that's r, the radius, and then level is the game level. What level in the game are we? Because the more levels you get into the game, the faster the asteroids get. So you need a way to tell the asteroid that in this particular level you've got to be going faster. Yeah. But we are calling the shape constructor X, Y, and R. Yeah. So the asteroid is still calling the shape constructor that says this is the X, this is the Y, and this is my radius. But I'm also doing some extra functionality in the constructor of the asteroid. So here we are. So when we construct the asteroid, I am doing a random pick out of 10. Yeah. I'm doing a random pick out of 10 to say what direction on the x-axis am I going. So if it's greater, out of a number between 0 and 10, if it's greater than 5, we're going right. If it's less than 5, then we're going left. We do exactly the same thing. We do exactly the same thing on the y-axis. Out of a random number of 10, if it's greater than 5, we go up. If it's less than 5, we go down. Or vice versa, I'm not quite sure yet. But it picks a direction, yeah? Then, this is where the level comes in. Because we have a level multiplier, which basically says it's 1 plus the level times by 0.1. Yeah, so level 1 will be 1.1, level 2 1.2, level 3 1.3, and then we use that multiplier. We use that multiplier to define the speed of the asteroid. So that is the speed of the asteroid. So we're taking the speed of the asteroid in the constants, which is 50, and timesing it by our multiplier. So for level 1 will be 50.5, and then 51, 52, and so on and so forth. And then that works out, then it gets translated into the x velocity and the y velocity. So basically what we're doing, we're taking... Hello, Mrs. OSK. So we're taking the velocity of the asteroid, dividing it by the number of frames a second. So if the velocity of the asteroid is to go 50 pixels over 1 second, then we divide that by the number of frames a second, which gives us the number of how far it goes per frame. Yeah? And then we times it by our direction, which tells us if we're going negatively or positively. And we do that for y as well. So we're taking the speed, the level speed, and we are dividing it by the number of frames, and then times it by the direction. So that always means that our asteroids will be going up and across or down in perfect 45-degree angles. There's no shallowness. This is what we'll do. We'll get into this for later on. Yes, but BODMAS, mate. BODMAS. Remember, BODMAS. Yeah? Multiplied comes before addition. If you remember BODMAS. But, you're right. To make sure it's implicitly... then yes, you would do that. You would do that. So we'll leave it at that, yeah? So you got to, so the asteroids are now set that they will either go in a 45-degree angle that way, 45-degree angle that way, 45-degree angle that way, or 45-degree angle that way. We haven't got any sort of variation of the angle, which we will get to later on because it'll be one of the challenges I will set. Yeah? We set the radius. Then we determine how many sides this asteroid's going to have. So I've got in there a randomization thing that says, please give me an asteroid of X amount of sides around our specific side generator. So I'm saying that typically I would want a 10-sided asteroid, right? But I've added half of that. So if you imagine this like this, I'll just put brackets in so it makes it easier to understand. So I'm saying, give me a random number of 10 plus or minus 5. Alright? So we should get asteroids of 5 sides up to 15. Somewhere around there. Yeah? And then I create the vertices matrix for those 10 sides. I set the rotation to 0, and then I work out what my rotation is per frame. And what I'm saying is I want to rotate 30 degrees, or a number for between 0 and 30 plus 20. So basically, I want to randomize the rotation between 20 degrees per second and 50 degrees per second. So we should get asteroids that are rotating at different speeds. Yeah. And then this is the jaggedness, the jaggedness, where people couldn't figure out how to make the jaggedness. Well, it's not that hard, right? You've got to think simple. Keep it simple. So we have got an asteroid that is between 5 and 15 sides, yeah? Following the radius that we've specified. So each of the sides would be following the radius, yeah? Now, to make it jaggy, you basically say, for this point, it's not that radius. So let's say our radius is 10, just for argument's sake. Let's say our radius is 10. We're saying for every point that it's going to generate, we're going to randomize the radius. So it's always 10 minus something. Yeah? So I've put the jaggedness, at the moment it's 1, and I'll explain why it's 1 in a minute. But what you do is you say, this is how much I want to randomize my jaggedness, yeah? And then you divide it into your radius, right? You divide it into the radius. So therefore you get a radius of minus x through to x, yeah? So therefore that means that each point would have a different radius. That is how that, well, ow. Oh. Oh, that did make me feel ill. Right. So that, you've always got to remember, you've always got to try and keep it simple. Always keep it simple. This is how I've done jaggedness, yeah? Now, I'm not saying this is the correct way of doing it. It's the way I'm doing it. Basically taking my radius of 10 and saying my jaggedness, right, is plus or minus, say, 4. So it could be a radius of 6 randomized up to a radius of 14. And that will give you your jaggedness. And I will show that in a minute. Then we've got the rotation. So we set in the rotation. I put a function in to say get me the galactic center of the asteroid, but I didn't even use it. And then here in the draw, I have changed the way the draw function works. So in the shape, we work out x1, y1, x2, y2 draw a line. Yeah. But in SDL, there is a function called draw lines. So you can give it an array full of lines and it will draw it. Yeah. And what you do is you give. It's very similar to polygon in Pygame, where you give it a set of coordinates. You give the polygon an array of XY coordinates. Yeah, and so that's what I've done. I'm creating an array of XY coordinates. So I'm going right. So this is the first vertices, second vertices, third vertices, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and I'll go right. Draw it, and it draws the line between all of the vertices until you come back in one instruction. We're not having to do it, and that's what's happening here. So I'm running through my sides and I am altering the x and y of that index in that array with the angle of that. That's where I had to overwrite get x and get y, because now you know about jaggedness, yeah? Now you know about jaggedness. I've had to put in now the index of the point that we're looking at. Because what we're doing is now we're saying here, radius times by my jaggedness. So am I 1? Or am I 0.4? Or am I 0.6? So if my radius is 10 and the jaggedness is 0.6, then 10 times 0.6 is 6. Yeah? Or if it's 10 times 1.2, then it's 12. And that's where I've had to overload these two routines, because remember, these two routines exist in shape, but they assume that all the points are on the circumference. Here, we're not assuming that. We're actually telling it, right, tell me what the x point for this when I've got a radius of 10, but I'm only wanting 60% of it. And then it gives me the xy for that. And that's why I've overloaded those two commands. Yeah. So I work out the x and y, I put it in the array, then I work out the next angle point and run through it again, and run through it again. That's the same as what I did in shape. And then for the very last point, I copy the very first point to make sure the line matches up. And then I just send it to the SDL library, and it plots all those lines. And then I've got an update which basically is doing the velocity. Yeah, so my x point is being added to with the velocity, either both a negative or positive number depending on which way it's going. Same with y, and then I'm testing for the extremes. I'm testing for the window. So if it goes off the window in this direction, it'll come back in this direction. And that's asteroids. Not a lot different to the shape. All I've done is overloaded a couple of functions because the asteroid is different. So if I run this now, we should end up with 5 asteroids on the screen going in different directions, hopefully with different rotations and different sides. And this is why you'll see why I've put the jaggedness at 1, so you can see the different sides. There you go. So we've got a 6-sided there. We've got 1, 2, 3. That's an 8. Right, 6, 8. That's a 7. There's no, that's a 6. Oh, that's a big one. That must be a 10. Is that a 10? Yes, that looks like a 10. So it looks like we've got 2 6s and a 7, an 8 and a 10. No, it's not. It's doing all right, the Pi 400, isn't it? It's doing all right. So this is why I've set the jaggedness to 1, because basically it's saying it's my radius times by 1. Yeah. So it's always going to give you the number of the proper shape, right? But if I change the constant for jaggedness, yeah. So this one here, if I change this and say, okay, I want a 40% jaggedness, yeah? If I want a 40% jaggedness. Now, if I run it now, we should get asteroids that look like asteroids. Whoops. What are you talking about? Get on with it. So we should get lopsided and funny shaped asteroids. There you go. So now that's 40% jaggedness. So basically it's saying that from my radius of 10, it's going to be plus or minus 4. Yeah. So it'll either be 60% of my radius or 140% of my radius. And that gives you your jaggedness of the asteroid. So the bigger the jaggedness, so if we go even bigger, so let's say, let's really put this to the test. Do 80%, yeah? So if my radius is 10, that means it's plus or minus 8. So it means it'll go from 2 to 18. These will be really serious shape asteroids. Let's see how bad they look. Be more like prickly things. There'll be spikes. I bet you. This is a serious one. Oh dear, I love this. I love programming. I love programming. So there you go. That's how a silhouette of an X-Wing. Yeah, I suppose it is, isn't it? I suppose it is. But as you can see, we've got random velocities. Which one's the Star Trek? Oh, right, okay. Oh, you mean that one? But that's what I'm saying. That's what that jaggedness constant's all about. Is how distorted do we want to make our asteroids? Yeah. So, I mean, I thought that a 20% distortion would probably be the sort of thing that we're looking for. So let's see. Well, no. I mean, even 20%. I mean, they look like traditional asteroids, don't they? They look like real asteroids in the sky, you know, roundish. But they're not jagged enough, are they? That's 20%. So they're not really jagged enough. So let's, because yeah, I mean, when I was testing this, 40% seemed to be the bet that it seemed to be the best before it went off world. So, well, before it went wild, before the asteroids went to a point where you think they're not asteroids. There you go. That looks better. But it allows it allows us to be as janky as C64 Mark says, or as realistic as we want with the jaggedness constant. That's what the jaggedness constant's all about. Is, do you want these asteroids to be mega janky and mega ragged, or do you want it with no and it just looks like shapes? But that's how you inherit and overload the shape class to make your asteroid class. So we're still using the functionality in the shape class. All we're doing is we've just overloaded get X and get Y, and we added a new constructor specifically for the asteroid, and we overloaded the draw because we don't want the shape draw to do this, because if I ran that out, then we'd just get the shape draw. Yeah. So here we go. Let me rem it out just to show you. So I'm going to rem it out, and then we're going to build it again, and we should get perfect shapes because it will drop back to the shape class draw. Yeah. Can you hear him snoring? Oh dear. So can you see all the asteroids now are showing the proper shape? Yeah, because it's now dropped back to the shape draw routine, which draws the perfect shape. Yeah, we've told it what the number of sides is, and it's just gone and drawn that shape. Yeah. So I'm going to unrem. Going to put back in our draw that does then the raggedness. And that is how the asteroids are done. So basically it's, so the difference between shape and asteroid is this array. So this array gives us our percentage difference for the radius. So that will be either, like I say, if we're doing 40%, so that's going to be a value of 0.6 to 1.4. Yeah. Then we overloaded the get X and get Y routine because we need to multiply that offset into the radius. Gihimstad, welcome. Happy New Year, mate. He's rattling that snoring out now. Oh dear. Yeah, dear. Oh, the background's gone again. Oh. There we go. Right. And then, so added the extra constructor and the draw. I mean, I put this in thinking I'm going to need this, but if I do find all instances of it, I didn't use it. I wrote it in, didn't actually use it. Didn't actually use it. So we can, yeah, we can rem that out because I'm not using it. Looks like non-copyright infringement asteroids. Well, we're getting there. Yeah, I know. I mean, well, let's just hope they don't. Let's just hope they don't come for me. I'm not selling it, so how can they say I'm copyright infringing it if I'm not selling it? So now we've done the asteroid. Well, I'm not calling it asteroids. I'm not calling it asteroids. Can you see? I don't know if you can see the file name. Can you see what I called it? CPP. Let's so you can see what I called it. Copy. Let's go in here. Zoom in. There we are. I called it CPP roids. Call it oddly shaped rocks. Nice. But yeah, I just called it CPP roids. So yeah, I'm not. Yeah, it's just for training anyway. It's just for you guys to get into C++, because I'm surprised how many people have been pinging me. How'd you do this? How'd you do that about this? I didn't think this would be as popular as it's turning out to be. So next thing we need on the screen. Oh my god, is that the hardware? That board looks very dusty. Oh, it's got the dimensions. Is that a cease and desist? Oh, kindly refrain. Kindly refrain. Wow, the language back then was very gentlemanly like. Kindly refrain instead of cease and desist. No, you can't use Mr. Bill or Sluggo, yeah. But it's kindly. Kindly refrain. Kindly refrain. Nowadays it would be cease and desist. Right, we better not use Mr. Bill or Sluggo then, yeah? Oh dear. Right. So, what's next? Well, we've got to build the player object. That's what next, yeah? So we've got the start of the asteroids, yeah? Meager Bill must be a bit upset. So we've got the asteroids now created in a simple fashion, yeah. Because we're going to we'll have to code some more. We'll have to put some more coding into the asteroid class because we'll need to put detection, collision detection in there. We'll have to put in code that says what happens to the asteroid when it's destroyed, and so on and so forth. Yeah. So it's not the end of the asteroid class. This is just the beginning. So we've got it on the screen. We've got the asteroids being drawn on the screen. And we'll come back to it when we start filling out the asteroid game, which you guys should be coding. This is not me coding. This is me telling you how to do it. You should have done it already. So, the player class, right? So you got to think about the player class, right? The player class, as this article shows. Here, there you go. The player class, as this article shows, is like a triangle. Yeah, but it's not quite a triangle. It's sort of a triangle. In your defense. Well, if you've got a laptop that's powerful enough, you could download the Raspberry Pi desktop. Yeah, I don't know if anybody's seen this. Yeah, I used to do this all the time. Yeah, I used to do this all the time. But there is a Raspberry Pi There we go. A Raspberry Pi desktop that you could run in a virtual machine. Yeah, but you could download that and run it in a virtual machine, which imitates a Raspberry Pi. Yeah, so it's Debian, but for x86. It has the C++ compiler already on. All you have to do is do the install of SDL. Yeah, SDL-dev I think it is. And you're away. And also install VS Code. Yeah, and you're away. You can do it. If your computer can run a virtual machine. Yeah. So, and learn how to use Linux. Well, that's one of the things I've been learning for a long time, is how to use Linux. Because of the Raspberry Pi, because I think it's a great little machine. I think it's a great little computer. And the more I can do on it, the better it is. And I've got the likes of 6502 Kebab that helps me out an awful lot, as well as GaryMeg on the hardware side of the electronics. You know, so, but the Pi 400 is my dev box. It's got all sorts of languages on it, even .NET on it. You know, if I do this, right? If I go .NET -- version, it might be a little bit old. Oh no, it's the latest one, version 6. Get in there. But I've got Node on here. Got Java on here. And then there you are. I mean, G++ is part of it. Yeah, I mean, Microsoft, the people, you know, it was Bill Gates, wasn't it, that did it? You know, who wants free software? And it's good that Microsoft are now going into open source in a big way. Like .NET Core is open source, VS Code is open source, and they're starting to open source some other products as well. The fact that SQL Server is now on Linux is a big step forward, because now SQL Server can be installed on anything. Yeah, exactly. Azure relies on Linux. Yeah. So yeah, it's Microsoft. I think Microsoft have seen the light. And as time goes on, you're going to see Linux get embedded more and more into Windows. I wouldn't be surprised if we get a Windows for Linux. Anyway, so we've seen how Windows 12 Debian Edition. Yeah. Well, I mean, you know, they've moved SQL Server onto Linux, and I love that, because it's the footprint for SQL Server on Linux is a lot less than the footprint on a Windows machine. SQL Server on Windows, it's a lot less. So I love SQL on Linux. I think it's one of the best things. When they announced they were doing it, I thought, yeah, this is they're now doing it. They're now taking it on board. Right. So back to the task in hand. How do we create the player class? So we have an idea of how the player should look. Yeah. SQL does run quicker on Linux than on Windows. I'm just waiting for the SQL server for Raspberry Pi. That would be cool. That would be cool. Anyway, so we've got the player, which is sort of an isosceles triangle with a dent in it. This is the player. He looks down on them as they just rocks, as they are just rocks, but looks up to him. An alien UFO. Yes, we haven't got to the UFO yet because the UFO does kick butt. It's got extremely accurate aiming. Well, mine does have it anyway. So for the player class. Now, how we're going to do the player class? We could use the shape class, but you're going to be rewriting. You're going to be overloading awful lot of the shape class because you're going to need. We're going to need to have a velocity. We're going to have momentum in there. We're going to have a concept of friction and stuff like that. Plus, we need to be able to tell whether it's been under power or not, and stuff like that. Now, we could use the shape class, but like I say, you will probably be overloading most of the functions because they will be different. To be honest, you're in space. There is no friction. Yes, I suppose. I mean, come on, we're in space and the asteroids have got gravity. Do we implement gravity? Does the original game not have? Does the original game not have friction? Really? Oh, adverts. Go away. He is slowing down. I thought it had friction, but he is slowing down, right? Look, he's slowing down. So the original did have friction. No, he was slowing down, look. Look, he's slowing down with no thrust. He's slowing down. Hang on. That is... Oh, how'd you play the game? Well, that's no good, is it? I mean, slowing down, look. Can you hear him? Oh, right. Or am I spelling asteroids wrong again? Oh, go away. Oh, it's not in here. It's not in here. Maybe you can't play it online. Coin op. Oh, have I done it again? Right, so it's not online. Maybe Atari have made sure that you can't play online the proper game. But you have it in main. I wonder if it's in there. Let's try this one. Search. Oh, this could be it. Oh, plugins required. That's not fair. I don't want to... Oh, here we go. Choose an emulator. Is it gonna run? No? Ugh. Arcade does not slow down after thrusting. Oh, right, okay. Right then. Okay. If that's the case, then we're not going to put friction in then. Oh, it does slow. Oh, it does. So I was right. Okay, right. We're putting friction in then. So the way I looked at the player class was right. The shape, because we're going to rewrite most of the functions in the shape class, it's not worth inheriting the shape class. So what's the class that the shape class inherits? Yeah, and the shape class here inherits the point. Yeah, so that's what I did. I created a player class. I created a player class that inherits the point class. Yeah. So I basically copied the shape class into the new player class and tweaked it. Yeah. So this is all in the shape class. This is in the shape class, but these aren't, right? So we've got the same. So we've got the set. Hello, Apollo I, welcome. I don't have a command for project. Basically, this is a New Year series that a patron asked me was to try and explain how to do classes in C++, because we're all trying to learn C++, because eventually we're hoping to use the C++ compiler to make a C64 game. So we want to get into C++. We're also using C++ for this little fella, the Pico. So we're writing stuff for the Pico as well. So that's the project. So the project at the moment is learning how to do classes in C++, and the thing that we're applying that to is the classic game Asteroids, that we're calling Roids to make sure we don't get a copyright strike. Right? So in player, we've got the same variables as we did with Asteroid. So we've got the directional X value, the directional Y value, the velocity X and the velocity Y. We've also got some other attributes that we need for the player class. So we need to know whether thrust is being applied. So we've got hello you, Mr. Snorehead. Yeah, he's awake. What time is it? If you overdo the roids. Has he gone downstairs? Oh, and he's just taken a tumble. And I can't go running after him. Right, I hear the tip-tap of feet on a hard floor, so he's hit the cushion as he's gone down. Right, so we've got some unique variables for the player class, right? So we've got a way, we need a way to identify whether the thrust has been applied. So thrusting is a Boolean value, and by default we are not being thrusted anywhere. We then have some XY variables for thrust, and basically that is the velocity of the thrust. Yeah. Then we've got the position. Play as a triangle. Well, it's not quite a triangle, mate. It's not quite. We could make it a triangle. Yeah, we could make it a triangle, but I didn't want to. I wanted to be different. I wanted to make it different. So we got position, we got velocity, and we've got angle of acceleration. Now I'm not using those three yet. We've got a variable that tells us if we've died, what our explosion time is when we're dead. Blink time, blink number, and blink on is invincibility. So while blink is on, we are invincible. We can't get blown up. Yeah. So it's when you respawn, if there's an asteroid on top of you, you won't die, yeah? And whether we can shoot or not, yeah? Because when you're in invincibility mode, you shouldn't be able to shoot, yeah? Then we're going to have a variable for our lasers, which is not being implemented yet, but I've put it in there to remind me that this is where I think the laser should go. And then we've got 2 sets of point matrices, one for the ship and one to show the thrust out the back of the ship. Yeah. Then we've got this, but I don't think I'm actually using that. Hang on. No, I'm not using that. So we will get rid of that. Not using that. And then we have some new functions cuts. So we've got some get X positive, which is basically get the positive way of X. Same with Y, and then the negative, which goes in the other direction. So, and you'll see why I've got this. We've got get radians for angle, because that's not in the point class, but it's in the shape class, and we need this to work out our radians value from our angle. And then we've got a new constructor for player. Yeah, got a new constructor for player. Whoa, you are very wobbly, mate. You fall down the stairs, eh? You're very wobbly. Don't knock the camera over. You're very wobbly, aren't you? Again. Oh, he's very wobbly again. Don't knock the camera over. Don't knock it over. I don't know why I'm talking to him. He can't hear me. I don't know why he's staring at me. Oh, he's going to wait. Oh, and his weight casting up now. Anyway, so we have a new player constructor, right? Because when we create a new instance of the player, it's always going to spawn at the same place. Yeah, it's always going to spawn at the same place, which is right smack in the middle of the screen. So basically, our constructor is just sending in our render space. Yeah, and then we run the constructor of point by saying do width divided by 2 and height divided by 2, which is right smack in the middle of our screen space. Then I've got a function that sets up the new ship. So basically sets up all the defaults and then sets up the points arrays to draw the ship and the thrust. Yeah. So then I've got some encapsulation. I got some encapsulated functions because we're not directly touching the thrusting value because it's a private variable, and we want to be able to instruct the player that the thrust is on and instruct the player that the thrust is off. So we encapsulated that variable so we don't get direct access to it. And I've also got 2 functions that work out when we rotate right how far we go and work out the new rotation value, and when we rotate left work it out and the new rotation value. Oh, he's pestering Aston, and Aston was asleep as well. So here's the new ship. So basically the new ship is setting up all those variables that we've just spoken about. All of them, it's setting them up. So a brand new ship is being put on the screen. This is what happens. So the X point and the Y point is the width and the height divided by 2. The radius is the ship size divided by 2, because remember the ship size is going to be a long thing, so the radius is half that to make the point in the middle. We're setting thrusting to be false. We're setting the thrust values to be false, to be 0. We're setting the position, but we're not using that yet. And we're setting the velocity. We set the angle of acceleration, but we're not using it. And we set everything else. So we say we're not dead. Yes. Yes. Rotate left and rotate right. I mean, really, it should be rotate port and rotate starboard, shouldn't it? I couldn't figure out which one it is. Anyway. Then we set the explode times, and then we set the default timer for the blink. So when the ship is put on the screen, the first thing it's going to do is going to blink, because it's going to be invincibility mode. Yeah. And then we're going to set the blink on. And in fact, that should be 0, I think, because it's an integer value, I think. Yeah. It's an integer value. Our port is left. I mean, we could change it, I suppose. Rotate. Rotate to port. Rotate to starboard. Rotate left and right is simpler. That's easy enough done. There you go. So, and we set that we can shoot. Now that's not right, because if we're blinking, shoot should be false. Really? You want to go out? Really? Hey? Daddy's got a bad back. We on the floor, you do it all the time. Alright then. Right. Right, I'm gonna take Buggerlugs out. Right, so I'm just gonna put it on the be right back. Talk amongst yourselves, and I'll try and be as back as fast as I can with my back, alright? Alright then, buddy, I'll take you out. Right, I won't be long. And we are back. Oh. And I've just taken some ibuprofen because I'm due it. Ugh. Plum colour. Right. What's this? So the arcade doesn't have invincibility. As best as I can see, when you die, you don't reappear until it's safe to do so, and it has no safe time once the player is back on the playing field. Oh right. You have roid rage. It's still a classic game. You was playing main while he was waiting. Well, he's not. Is he upstairs? Oh, trying to turn around. Turn around. What are you looking at? I have no idea what he's looking at. Right. Okay. So, and then there's a bit of code that would clear out the laser, because I think for the laser we're going to have a queue, because it'll be we'll create a laser, yeah, and then we'll get it to run through its lifetime, and then it dies, and basically it will always die in order that it was put in, and the best data structure that describes that is a queue. The first laser gets put in. Tried flying into my own bullets to see if I could kill myself. So the lasers would... So first in would be the first to die. Second in would be the second to expire. Not die, expire. So that is a queue. That describes a queue. And I did some looking up, because you'll see that there was a URL here, there, when I was reading up about C++ queues and how we can use them. So this would be the way to clear out the queue if we needed to do a new ship. Got the rotation in there because we're inheriting point, we won't have the rotation function. Oh, this is in there, but we don't need it. Now, the draw. Oh, this is where it gets real fun. This is where it gets real fun. So let's get this so you can see it full screen. So, on the draw, we're going to be drawing both the flame and the ship, yeah? So, in essence, what we're going to be trying to do, so here comes Old School Coder's famous drawing. I wonder if it's better. Oh, I haven't got it installed on this, have I? Hang on. I haven't got it installed on the Pi, but I have got it on here, haven't I? So let's just make that bigger. New file. And we're going to say it's a draw.io file. There we go. File, save it. We'll put it somewhere out the way. Where's my temp folder? There we go. Oh, I'll do that later. I'll do that later. Right, so we're going to be drawing a ship, and it's going to be more like something like this. So let me see if I can do this. Can I make that fatter? There we go. So you can see what. So we're going to try and do something like this. So let's copy that. Copy. Right, I want to invert it. Can I invert it? Oh, I thought we could invert it. Never mind, we'll do it this way. That looks about right. What? Right, that's center. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Not far enough. So we're going to make a ship that does that. Then we're going to have it do that. And we're going to have it do that. So a Star Trek logo. Oh. Yes. Yes, I suppose it could be. I suppose it could be. So our point. Can I put a dot on here? Ah, there we go. Do that. There we go. Our point, our center point is roughly, I think, about there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So it's not, it's there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that's our center point. Yeah. And so we have to work out these points here. Yeah. So let me just grab that and move it down a bit. There we go. So if we draw another line, so if I copy this and then paste it, and we'll change the colour to a bit more friendlier red. There we go. Change the colour, and we then put it on our centre point. We can say that that is our radius. Yeah? So paste. So I'm going to put the that is our radius. So how am I gonna? Oh, I can rotate it, can't I? How do I do rotate? Oh, I'm sure I could rotate. Oh, that's annoying that you can't rotate a line. I thought we could. Alright, I am going to pretend that that's it. Yeah. I'm going to pretend that that's our point. Yeah. Yeah, I suppose so. Hang on, let's draw a circle. Not that circle. That one. So let's. Oh, that's annoying. That is annoying that you can't center the circle. There we go. Right, a little bit more. There. Right, we'll send that to the back. There we go. All right, okay. Okay. So that would be there. So I need to change. I need to change the diagram because it's not quite like that. So these need to be brought back a bit to about there, I think. God, the level of concentration. There we go. Control R to rotate a shape. Oh, now you tell me. Oh, it's greyed out. All right, FaiRLane. See you next time, yeah? Right, so we've got our ship, yeah? We got our ship. And so we're still using angles, yeah? We're still using angles to find our points. Yeah, so our points are going to be 1 point there. So let's put the points on there. So there'll be 1 point there. Let's make that. Bring it to the front. There we go. And we will give it a colour. There we go. We'll give it a green. No, blue, 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 blue. Give it a blue. And then we'll do another spot, which will go there. Blue. Bring to the front. And another spot, which will go there. Roughly. And these are the points that we're going to be working out. These are the points we're going to be working out, and we're going to be using we're going to be still using Pythagoras and all that jazz, yeah, because we can work out these points. Now these, the points are roughly about there or thereabouts, yeah. So let's that could be about right. Right. So what we are saying here, right, let me see if I can do something else. Have we got any text? Can I plonk text on here? I should be able to just type, shouldn't I? Aha! Text. Nice. Let's boost it up. There we go. Right. So this point here, let's say, right, it's roughly 3/4 of the radius. I'm just looking now, and I think I've got it wrong. Hang on. I think it's more. I think it's more this. I'm just looking at my maths. It's more this. Come on, where's the other one? Where's the other line? There it is. Right, it's more that. Ooh, what happened there? There we go. So this point, right? This point is 4/3. I know the drawing's not to scale. Don't shoot the messenger. But it's 4/3. So let's say if the radius is 10, then this point is going to, well, let's say the radius is 3. This point is going to be 4, yeah? And same with this point here. It's going to be 4/3. So let's copy that, paste here, and paste here. So these points are going to be 4/3 of the radius, yeah, outside, because this circle is going to be our collision detection area when we get to the collision detection area, right? But this point here is not 4/3. That is actually 2/3. So that is 2/3 of the radius for so when we're working out the maths on the ship. Yeah. Let's just check chat. There we go. You can see what I'm doing now. So we need to work out these 1, 2, 3, 4 points. Yeah. And then we can actually put them on the screen. So here we go. So this is the calculations to work out the 4 points. So we're taking our radius, we're multiplying it by 4/3, and then timesing it by the cosine of our rotation value. The top point of the ship is our y point times by the radius 4/3. So it's, but this time we're doing the sine of it. So that works the ship top point right at the top. Yeah. Then doing the bottom left. So that's that way for me anyway. So we'd work out that point, which is exactly the same thing, 4/3, but we're timesing it by the cosine of our rotation value and add in the sine value because it's not directly below, so we're having to do it You are very welcome, Volmancer. You are very welcome. I find some nuggets of extensions for VS codes that guys like. I also use it in my profession as well. So, and it costs a lot less than Visio. That does help. But thank you very much for the kind comment. So once we've worked out this point here, so remember, that's why we're having to do the plus sine value, because we're having to work out this point. Then transversely, we're going to move to this one, which is this point on this side, yeah, which is this point on this side, and that is the opposite of this one. So if you notice that the plus and minus are the other way round, yeah, because it's the opposite, right? And then the middle is what we would expect normally, but what we're saying here, so it's the same as the top, but the difference is we're saying 2/3 of the radius times by the cosine and 2/3 of the radius times by the sine. Night night, Mrs. Ice K. Chat to you later. And so they work out our four vertices, our four vertices, XY coordinates. for the ship to make this triangle, isosceles triangle with a cutout, to make that. Alright? Now, you're probably going, oh, John, there was some code up the top. Yes, you're right. This code here is for the flame. Yeah? So what's happening here is we are creating the flame out the back. So I'll just do this because it'll be nice and easier to do this. So let's boost the... So the flame would be coming out the back like so. Like that. So to speak. Let's flame. Fill. Get rid of the fill. There we go. So the flame then comes out the back. Yeah. Now the flame is 2/3. The top of the flame is exactly the same point as the cutout. So it's 2/3 of the radius. The bottom of the flame down here is going to be 8/3. So that's 8/3 of the radius. So it's going to go out by twice and a bit, so to speak. And the other side, these two sides here, the two sides here are this. I'm just trying to work this out, and that's not right. That's not right. That's right. Hey FaZe, welcome. That's right. So we're not quite to scale. We're not quite to scale because these will be a bit further up here. So let's just squash it a little bit. It'd be more like that. It'd be more like that. Alright, so then we go back to the code, and that's what we do. So the thrust bottom point, or the top point's at the bottom, is 8/3 of the radius times by the cosine and times by the sine. And then we've got the two middle bits, which are the 4/3. And then we've got the top bit, which is the 2/3, which is the point of where the ship is. So we end up with something that looks like that. Just using simple Pythagoras mathematics based around our radius, which is going to be our collision box when we get, well, collision circle when we get to it. And then we just set it. Alright? So that's the drawing. Here, this is where we actually perform the drawing. So if our explode time is 0, that means we're not dead. Yeah? And we're not in the invincibility mode. So we're not dead because there's no explode time. But if blink is set to 0, we're going to draw the ship. But if blink is set to 1, because blink is 0 and 1, 0 and 1, it won't draw the ship. So there it gives the impression that it's blinking because we always set the canvas to black on the next frame. Yeah. So that's how we do a ship. So if we then bring back in our player, So I'm entering the player and then do and just run it. We should end up with a ship on the screen. There you go, it's flashing. That's the invincibility mode, and then it'll go solid. That means now we are there. It's the ship. Duh. So, yeah. So that is the ship. So if you imagine this on its side. So if we, let's see, can we rotate this? Control R. Can we rotate it? Oh, I don't think we can rotate it, can we? Do I have to group it to rotate? Aha! Rotation. Oops. Undo. Undo. Right, arrange. Direct. Right, so we need to group it all. Right. Direction, rotate, 90 degrees. Oh, it's not done it. It's not doing it. Ah! Oh, that's annoying. Oh, well, you'll have to pretend that it's rotated. Yeah, it's not doing it. I've grouped it, but it didn't do it. Annoyingly. Annoyingly. So you'll have to do that. But that's the shape. That's the shape. So, how do we get thrust to work? How do we get thrust to work? Well, if you noticed, a monitor is on my arm, so I just rotate that. Me, I turn the head. So if you noticed that we've got a player draw, which is drawing a player, and then a player update, right? So if I go into back into the player class, the player update is down here, look, right? So this is where it's doing all the update to the player based on what it's been told from the outside world. So it's doing a blink. So it's doing a blink. So it's doing a divide by 2, yeah, and it's giving me the remainder. So it's dividing the blink number by 2. So it'll always, as soon as the blink number's got a value, it divides it by 2, and the remainder is what we keep in the blink on. So it'll always be 1 or 0. Every time it does the loop, it'll be 1 or 0. Yeah. So if the blink number is greater than 0, which it will be, then it's going, of course, it's going to go through the invincibility blink scenario, right? So what we're doing is we're minusing blink time. If blink time is equal to 0, then we're setting blink time to the ship blink time times by duration times by the number of frames a second, and that's to give the blink effect, yeah? And then we minus the blink number again, because the blink time is the time it stays as such. So if the blink time is not 0, it's not going to do the next blink calculation. It's going to wait. So it'll be put on, run the time down, take away, run the time down, put on, run the time down, take away, run the time down. So that's how it does the blink. Now thrusting, this is where we apply our ship thrust constant to our thrust values. Yeah. So the thrust x value is adding the ship thrust value times by our directional value to give us our thrust over for our thrust per second, and then we divide it by the number of frames per second to give our thrust per frame. that will then show how we can get the ship to slowly increase in speed, because the longer you keep the thrust on, the faster it'll get. And we do the same for the Y value. But as soon as you stop thrusting, right, we are using friction as our value. So we then work out what the friction of per second against our thrust value is, and then divide that by the number of frames per second. So it slows down the value in thrust. So it makes it smaller and smaller, which gives the impression of deceleration, yeah? But it also gives the impression of momentum, because when you take your finger off the thrust, it's still going, yeah? We've got the explode time. What the friction is set to 0.7. So 0 is none and 1 is lots, yeah? Explode time, this is when we're going to die, yeah? So if the explode time is equal to 0, which it is, then we set our x, y points with the... Sorry, we add to our x and y point our thrust value, our complete thrust value, yeah? But if we've got thrust an explode time, that means we're dead, yeah? We're dead, and we're running through the explosion cycle. Hey Warlock, I hope you've got your coffee. It's been a long time since I've said that. So, in Spitz. So the explode time is when we're dead, and we're going to have a... So when we have collided, we're going to have a process of explosion, and that's where explode time comes in, because that allows the explosion to be performed. We don't know how we're going to do the explosion in the Pygame version, which I've got here just in case we need to run it. The Pygame version, the explosion just does circles, yeah? So if I'll wait for that asteroid to get to me. There you go. It's just circles, but someone said the original does, the ship breaks apart. I think it was 6502 Kipab that said that. And so I looked it up, and the ship does... I wonder if this guy dies anytime soon. Ooh, that was close. Go on, fella, you're going to die soon. Come on. He's got to die soon. Oh, he's doing well. Isn't he? Does he die? Car. How did he not die? Well, he plays it better than I do. Anyway. The ship explodes, I'm sure it does. There. Back up. So he got tagged. There. So the ship explodes. Oh, sorry, mate. In the arcade one, it puts the player into single line of the ship and moves them outwards for a bit. Yeah. So we may do that, but this is part of the explode time. Yeah. This is part of the explode time. So there's going to be a time delay while we go through the explosion, and then when it hits 0, we create a new ship. We reset the ship. Yeah. And then I've got some tests to make sure that when the ship goes off the screen, we end up on the other side. Yeah. Now, how do we control the ship? How do we control the ship? Well, we're going to be using the main game loop to control the ship. Yeah. So in the main game loop down here, we do, courtesy of 6502 Kebab, he showed me how to do this. You poll the SDL library with the event. Then we test to find out what the event is. So by default, you would test for the SDL quit, which means the little cross on the window, and then you'd say running equals false and break out, which means that then the main game loop, done, dusted, sorted, it drops out. Yeah. Which is the similar sort of thing that we do in the Pi game version. We've got the game loop and the main game loop, yeah? So the next thing we need to test is for the key down event. Are any of the keys being pressed? Yeah? So then we can test for the scan code key. So here I'm doing a switch, which is a case select if you do VB or anything like that. Switch is basically, I'm going to test this value with what I've put in here. So I've got case, scan code key space. This is going to turn the thrust on. Yeah. Then I've got scan code right, which then is going to rotate the ship left. That threw me. I put rotate right, and every time I went right, it's going the wrong way. Not checking for down arrow through hyperdrive. I didn't know. But we can definitely put it in. And then scan code left, which then rotates right. Yeah. We also can check the key up, right? And we need to do that because when we let go of the space bar, we want the thrust to stop. So then we test the scan code key in the key up event for the space bar. So basically the space bar is now up, and then we turn off the thrust. Yeah. So basically, if we run this now, make sure I'm on the right one. We should be able to move around the screen. There we go. So we'll let the blink get. There we go. So we're now in full play mode. So here we go. Going to rotate. Right. Left. Rotate right. Rotate left. So our rotation is working. Now if I press the space bar, it should push us in the direction we're pointing. There you go. And we can rotate and then push back. Oh, look at that. 2 keys down at the same time. Nice. So I'll let it die down. There we go. So the friction is coming in and it stops it. Right, let's put the thrust on and rotation. Let's see what happens. Ooh. There we go. Right. Thrust on, rotation. Alright. So now what we need to so we've got it to move around. We're not going to do any collision detection because we're trying to get all the aspects onto the thing. So the next thing we need to do is the lasers. I'm just wondering now whether spacebar is a good thing for SP. What's thrust? Is it arrow up thrust or spacebar in the real game? What did I put in? What did I do it in VS Code? What did I do it in VS Code? Game. What was? Oh, right. Okay. I've done this wrong. It's up. Because I've just checked my Pygame version. It's up. There we go. Space bars for fire. Right. Well, my Pygame one, I've done up as thrust. So if I press up now, there's thrust. There we go. And then the spacebar will be fire. So what we need to do now is we need to start thinking about lasers, right? We need to be able to shoot. We need to be able to shoot. Now, in the player class, we've already started thinking about lasers because we've put the variable in for it, and I think it's meant to be a queue. Yeah, it's going to be a queue of laser shots because first one in will be the first one to expire, last one in will be the last one to expire, and so I think we need to use a queue. But how are we going to build the laser? Are we going to use a class or are we going to embed it into the player class? Well, in the Pygame version, I made laser. Were they points? Well, we've already seen that a point on that is very difficult to see. If you remember, when I put a point on the screen, it was very difficult to see. So I'm not going to be using a point. What I want to do is to do say a circle, so it's a bit more obvious. Yeah. They are squares, so a small square. Yeah, I suppose. Yeah, I suppose. Or we could.
Hi, John here. Another subscriber. Stay
What?
a while. Stay forever.
What? Oh, Warlock!
Another subscriber. Stay a while. Stay forever. Hi, John here. Another subscriber. Stay a while. Stay forever. Hi, John here. Another subscriber. Stay a while. Stay forever.
Warlock.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Warlock. Thank you very much for your generosity, mate. Happy New Year to you as well. I don't do this. I don't do this for the subs or anything like that. As I tell Docster, because he's the man that he seems to be single-handedly funding this channel with his gift subs.
Oh my god, more bits? Thank you very much. You got
Oh, SP, you naughty boy. You naughty boy. Oh dear, Mrs. OSK. Oh, I'm not telling her. But thank you very much, Warlock. That is most generous of you. And SP, thank you for the 100 bits. You know that lot goes to Buggerlugs and, you know. Oh, how the hell is he sleeping? How the hell is he sleeping? Look how he's sleeping. Doesn't he look like a Sooty? Doesn't he look like Sooty but a white version? I've got to sort the focus out on that camera, haven't I? I've got to sort the focus out on that camera. I'll do it later. How does he sleep? But the bits go on them. Bits go on them. They get treats out of you guys with the bits. But thank you very much for the gift subs. They are much appreciated, and your generosity is. Thank you. Oh, my background's gone all funny again. Got to sort out my bot. Let's do a random again. Do a random again. There we go. Ooh, purple, purple. Right, so we need to think about lasers. How are we going to do the laser? Now, a point, I think, will be too small, because when we put a point, I mean, we could put a point on there. Let's put a point on there, right? So, let me grab the code that we did in the tutorials. Let's grab that code, class tutorial. I think it was it tutorial 1? Nope. I wonder if it was shape, inheritance, polymorphism. No, it wasn't that, because that was cat and dog, wasn't it? So it must be that one. Yeah, it's in there. Right, so I need where's the, oh, it must be at the bottom. Must be at the bottom. Yeah, there it is. There it is. Just grab that. And we'll put it in here. We'll put it in there. So we'll do that. So we're going to put it at 300, 200, yeah? And we are going to make it yellow, yeah? Yellow. Yeah, I mean, I'm trying to, I'm reading up about doing images, because we're talking surfaces and stuff like that. 6502 Kebab was on about it, because he was on about, why don't I just make the shit as an image and just rotate the image? But I wanted to explain the class by using lines, yeah. So I'm going to put a point on the... So if we run this now, we should have a point on the surface. But the problem is... Okie dokie. The problem is... I mean, we could use it. We could use it as a way of doing it. But where's the point? There. It's there. It's that is one pixel point just there. Where I've got my mouse pointer, it's just above that. So I think a point would be... I think a point would be useless. Yeah, they're not points, are they? They're little squares. I think they're just trying to represent a pixel, aren't they? But we can definitely try something out, yeah? Or little well, I mean, I did them as little circles in... I did them in little circles in the Python version, yeah? So if I fire up the Python version again, so if I fire up the Python version again, so if I yeah, they're little circles. I made them little circles. So we could do the same thing in the C++. Yeah, it's got sound in it as well. I mean, Warlock, have you actually seen our myriad conversion in Pygame? I don't know if you've ever seen it. Right. Okay. So let's show you what we mean. Right. Right. So we reverse engineered this game. Yeah. So let me fast forward to where it starts. There we go. We reverse engineered this game. Myriad. Yeah. And then we recoded it for the 64. We recoded it back for the VIC. We recoded it for the Commodore PET. We did it for the 128, the Commodore 16, the Plus4. Yeah. Then, I think it was last Easter. Last Easter, I think it was. We did 24 hours. 24 hours worth of streams in what, 4 days? 5 days? And we created a modern version of it. So let me load it up. Did I not? Oh, I didn't put it in the Patreon repo. Okay. That means it's in here somewhere. There we go. Right, so this is the modern day version of Myriad. So you've just seen what it looked like. What it looked like for the VIC-20. Here you go. This is what we did in 4 streams. I think it was 26.5 hours. So we did 4, was it 4 or 5 streams? But total of 26.5 hours. Right, so we've got easy, normal, hard, oh no. So we've got, and it's still, we still we still spoke, and he was on our streams as well. Steve was on our streams. So here we go. Press F1 to start.
Ready, set, go. Round 1. New high score. Round 2.
Come on.
Round 3. Medic. Round
4. Where's the... Oh, power-ups don't come up yet. Ah! Whoa.
Round 6. Medic.
I'm not going to get off level 1. I'm not going to get up. Oh dear. Who did the voiceovers? It was all public domain assets. Everything that we used there originated from free public domain assets. Yeah, so all these assets here are free. We trolled several websites. Some the aliens were free assets, but who was it? Saucy? Was it Saucy? He resized some of the assets. He did the backdrops as well. You know, the backdrops that's in the background that's come down, the space scenes. Hang on.
Ready, set, go. Round.
Yeah,
1.
this backdrop. He did them. He made them continuous, so we could roll the backdrop continually in the background. So, and he's done it that you can't see the join. He did it so you couldn't see the join. So, but every asset was we looked on the internet. We found sprites and all sorts, like the rocks. We got asteroids and all that jazz. So, you know, there you go. There's an asteroid. All free to use, all public. So that's why I've got pyroids, as I call it. Yeah, because this game here was me testing to see. Sounds sore. This was done before Myriad to see if I could create a game properly in Pygame. So this was my very first game, testing all the different aspects, sound, mechanics. Oh, I missed it. And again. How did I miss that? I'm waiting for the UFO. There are creams for that. I'm waiting for the UFO. Come on. There he is. Yeah, I did it as a random time thing. But that's what started the Pygame. So so the whole point of this is one of the patrons asked about how do we do classes in C++, because we've been messing around with one of these fellas. In December we did a Pico advent calendar, and the tutorials were done in MicroPython, but we wanted to do them in C++. But then when we got into more complex coding, like classes and all the other things that come with classes, some of the guys were getting a bit confused. So one of the patrons asked me if I'd do some streams on how to do classes in C++. So we're using asteroids as our thing to build. Yeah, we're using our asteroids to our things to build. You still need to open your Pico Advent Calendar. That's just mad. Mine's still here. Mine's there, look. I'm still messing around with it. I'm still messing around with it. I love the NeoPixel thing. I'm gonna buy 3 meters worth. I think that's what it was. 3 meters of NeoPixels. I've also been looking at. Do you know the Matrix? You know the Matrix on the bot down there, right? Let me get out of the way. Let me try and get out of the way. There we go. Let's get out of the way so you can see it. So if I do this, so the look, hello, there it is. Oh, hang on, let's make me big. Whoops, wrong one. Oh, wrong one. There we go. Let's do it again. There. So that's where the bot is, yeah? I've been looking and I've been investigating these. Where are they? Aha! There. These fellas. This one here. This one here. The 8 be 32 be 256. And I've been thinking of actually getting 2 or 3 stitched together, and then I can have that little matrix down there as a big colour one going over there. Johnny's going to do RGB overload in that room. You've unleashed a monster, I tell you. I love these NeoPixels. I've been messing around with them. I absolutely love them. So I've been thinking of getting one of these or 2 of these and sticking them up there, so I can have the bot, instead of having the matrix down there, put it up there so you can see it in big NeoPixels and have them in different colours and everything. So yeah, that's what I've been thinking of getting. Yes. NeoPixel Pac-Man. Oh. Now there's an idea. NeoPixel Pac-Man. Because if we put enough of these together, but that's going to cost a lot of money. If one of those is costing 15 quid and that just gives us 4 characters. Oh no, it's not 4 characters, is it? Yeah, it's 4 characters. Yeah, it gives 4 characters. Yeah, we'd need a 320 by 200. So how much is that going to work out to? Hang on. So 320. So that means we need 10. We need 10 going across. And 200. So that's... 22, isn't it? That's 22 going down. No, it ain't. Yeah, 22 going down. So that's 22. Yeah, we'd need 220 of them at £15 a pop. That's a lot of money. That's a lot of money. Yeah, 450 quid just to do Pac-Man in NeoPixels. Oh dear. Oh. It'd be cool though, wouldn't it? It would be cool. Oh, let's see what's... Oh, adverts. Oh my God, Snake! How awesome is that? How awesome is that? Oh, that's that would be awesome. That would be awesome. I still think that a NeoPixel Pac-Man or something like that. I'm getting 3 meters of LEDs, yeah. But if I can get them, if I can get these like this, even if we do a small one, let's see if we do a small one. Because we could, if you think about it, we could. I mean, 320 by 200. 320 by 200 is sort of C64 space, isn't it? Yeah, 320 by 200 is C64's number of pixels, isn't it? Yeah, that would fill the bookcase and some. So we might have to do it probably smaller. We'd have to do it probably smaller. I have to buy. They're not all my books. They're not all my books. They're only a selection. I have too many. Yeah, quarter scale it. So that would be what, 320 by 200. So that'd be 160, 80 by 50, wouldn't it? 80 by 50. Which is probably it there. I mean, to be honest, it would be 32 wide, so that'd be 96, wouldn't it? 96. What? So 96 wide and 50. So 48, isn't it? So that's 6 deep. So that would give us 96 by 48 LEDs. That would be the closest we could get. Yeah. 5 wide by 3 deep. And that would give us 80 by 50, yeah? Up, down, left, right, in and out. Anyway, we digressed. We've gone off topic. Oh, I'm gonna have to sort out this bot. Gonna have to sort this bot. I don't think anybody's done 3D Snake. Well, I've never seen it. I've never seen it. Yeah, that's what I was thinking. Yeah, the 5v3. I think we could get away with that. I think we could get away with that. Hey Nicomo, welcome. Right, so how long are we was on that? So we're now coming back. Coming back. Well, I got 96 by 48. I got 96 by 48. I think we'd be able to do 96 by 48. Which is 4 by 6, yeah? It's not 16 wide, it's 32 wide. 32 by 8. Have I still got it? Yeah. Look, it's 32 by 8. 32 by 8. Yeah, if we go for this big one here. So we would need 32, 64, 96, isn't it? Yeah, so that's 3 by 6. No. The original one, the ones down there, is 32 by 8. Yeah, so we wouldn't be. If I wanted to, I mean that's what they can do, and that's how you would connect it up. But if I wanted to replicate what I've got down there with the red LED, but using colours, I'd use this one because it's an exact match, 32 by 8. Yeah, but if we want to do Pac-Man, we'd need a bigger surface area. Anyway, we spent a lot of time on that. We digress. Now back to this. So we're talking lasers. Now, still using the object orientated approach. Cool, that takes a bit of getting out of, isn't it? We would then sharks with freaking lasers on their heads. Well, at least you'd tell they were coming. Austin Powers, I've never seen it. I've never seen those films because I thought they were rubbish. I saw the adverts and I thought, I've never seen any of the Austin Powers movies. Sorry. I will look them up and watch. I'll do a watch. Right. So lasers. So we need. Oh, behave. I know that one. That's right. That's John's next Christmas gift sorted then. Ow! Ow! I think this heat pad's turned off. Hang on. Yeah, it has. Turn back on. Ow. Right, so lasers. I'm going to get this laser thing out if it kills me. So lasers. We are... No, I've done my back in, mate. I did my back in last night. I playing pool, bent over the table to take a shot, and my back just gave up. Went into spasms. Yes, it wasn't a pleasant sight. It wasn't a pleasant sight. So I've been under the chiropractor this morning as she cracked my back and told me what the problem was. But that's not why he has a heat pad. Not his attempt of saving money on heating. Well, that's why I've got my hat on. Yeah, I bought heat pads, lasers. Yeah, I bought heat pads to try and keep me warm this winter instead of putting the central heating on. Right, lasers. I'm gonna get there eventually. So lasers are going to be an object in its own right. Yeah. So what we need to do is we need to create a class for laser that I think we can get away using the shape class. I think we can get away using the shape class because the laser are going to be small enough anyway. That makes sense. I was wondering what makes sense, mate. Your central heating's not been working since Christmas Day. Oh, the hat. Yeah, I haven't put the central heating on. It costs £10 a day to heat this house, and I'm not giving the energy firms £10 a day. They can sod off. I'd rather have these heat pads. Yeah, because the boys have got one. The boys have got one. They got one in their beds. That's why they're snug as a bug in a rug down there. This heat pad costs like 2p an hour to keep me warm. So yeah, so I'm doing that, and because I've got solar panels now in the daytime, it makes no difference because I don't use any electricity from the grid. Anyway, so lasers. So we're going to create a class, and the class we can inherit is the shape class because I don't think I don't know. December was quite good. December was quite good. I generated more than I thought. I generated more than I thought in December. I mean, that's today, which wasn't a particularly good day. But I think it was Monday. Yeah, Monday we generated an absolute truckload. Device. Can I do an overview? I mean, so far this month, I've done 10 kilowatt hours so far this month. Yeah, so far in January, which is day 4. No, past 30 days. Sorry, the past 30 days. Yeah, past 30 days. 9 kilowatt hours in the past 30 days. But yeah, I'm not doing too bad. Not doing too bad. In the summer is where it's gonna, and the guy's coming to fit the intelligent immersion heater controller. So any spare electricity that I'm currently pumping out for free, it's gonna heat my water up. Your bill was your first bill is what, $45 a month? That is just obscene. Before I had solar put in, before I put minus $45. That's even worse. Right, before I had solar, my average electric bill, right, was, now this is retrofit priced with the new price, up the price increase we've just had, was £375 a month in electric, right? And that's with the UK government price cap on it, yeah. So, but then, so that was September. So October is when I had my panels installed. When I had my panels installed, and my electric bill went from last October, so a year ago October, I looked at the energy usage I did in October, and the energy usage I used in October was it was equivalent to 420 something pounds, right? in the modern units, I only used £67 in electric. £67. That's how much I saved with my solar panels. During the day, I am exporting most of the time. I mean, you've just seen what happened today. Let's look at it again today. So this was today, right? So if I turn everything off, that was my grid usage, right? So between 9:30 in the morning to 1:45, I, except for this blip here, I use nothing off the grid. Like the pawn behind you, they're not taking much. But I did have a good. See, yesterday was a dull day. Yesterday produced virtually no electric, but it was, I think it was that one. There we go. Was that one or was it that one? Yeah, that one. That's when I put the washing machine on, because I was generating a lot of power, so I put the washing machine on. But yeah, I am safe. I've worked out. So I've had 3 electric bills now. I've had 3 electric bills, and I've saved over 64% on every one of them. So my December electric bill was hang on. Oh, we'll be back, don't worry. Let me just tell you what it was. Right. So, back. Oh, I thought I could see my bills on here. Oh, here it is. Right. My December electric bill. So ignore everything else. Here we go. My December electric bill was £62. I've never ever been less than £300, and here I am, £62 because of my solar. Because the solar array I've got, if it's a really rainy day, then I don't generate electricity. But if it's a normal cloudy day, not a brilliant sunshine but cloudy day, that produces enough juice to power the entire house. If it's a sunny day, I'm chucking out electricity for free. That and not using electricity. Heating, yeah. No. I do cook because my gas bill... Right, so... December gas bill was £99, and that's just by cooking and heating water up, heating the hot water up. That's why I want to put the smart immersion heater in, to reduce the gas take for heating the water up. Anyway, back to lasers. Back to lasers. So we're going to create a new... Yes, we're going to create a new class, and we'll call it laser. So let's take shape, and we will import that lot. Put it in. Now, I don't think we need to import it because... Am I importing point? Oh, we might have to import shape. We'll import shape just in case. Include shape. Just in case. So, right. So class laser. And it's going to be, we're going to inherit the shape class. Oh, public, not global. Blah. So we're going to inherit the shape class. Do I need... I don't need an exclamation mark at the bottom end, do I? Oh yeah, I do. Okay. Keep forgetting. Sharks in space. Right. So we're going to need, let's protected private public. Right, so laser, we'll have a public one of those. Now I think shape has one of those. It's not complaining. Yes, it does. Oh, John's on a roll. Right. What do we need? We need this one. We need this one. So let's just grab that. And we'll put this in here. Right. So this is now going to be shape. And we're going to be sending in the render space X, Y, R, and the sides. I'm going to say, what shape should we make the laser? Because it's going to be small, and I don't want to make a circle because that's lots. So I reckon if we do a pentagon, yeah. I think we should be okay because it's going to be small enough, yeah. Yeah, to make I mean, we can do a pentagram. Just have to work out the array points. Shooting triangles. Yeah, we could do triangles. Well, let's do that. Shooting triangles. So 3 sides. Yeah. Right, 3 sides. So we're going to take in the X, Y. I'm just wondering about R. I'm just wondering about R. I don't think we need to bring in R. No. I think what's the ships? In fact, we could make that a constant, couldn't we? So we can modify it if we need to. Ooh, 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 ooh. John, don't mess about with that. Where are you? Have I got it in here? Yes, I've got some laser. Here we go. I've got some laser. Got some laser constants, so we'll stick them in. So these are out of the Pygame version. So I might as well use the same constants. But I do not have a size. I must have hard coded that in. Let's have a look. What did I... Oh, right. It's the ship size. Right. Okay. So, ship size. So I've put... Now I'm not too sure that this is going to work. Now if I do that... So 30 divided by 15 will be 2. Let's make it 10. Oh, can't see. Nicomo. John's problem if his bot falls over. Cheers, mate. Right, so this is what we're going to do. So we're going to send in the ship size, divide it by 10. So that means the ship size is 30. That means that the radius of the lasers are going to be 3. Yeah. What is a header? Oh, I'm not even entertaining headers. I don't want to confuse anybody. We'll get to headers eventually, but not at the moment. Right, so a laser. So we've defined how big it is. We've defined. So what do we need? We need some private variables. In C#, yes, I would, but in C++, I am learning C++ just like everybody else. So I know that you have H files and but yeah, we'll get to that later. Right, so I want velocity x. We'll set it to 0. Float velocity y set to 0. What else are we needing? Oh yeah. Distance travelled. Right, distance travelled. So we need a distance travelled. So we'll use int. We'll use int to start with because I'm not sure. Yeah, the speed, yeah, that's the Vx and Vy. Position is already in shape, you know, X point, Y point, yeah. Oh, we need a flag to say that we're done. That the bullet is done, yeah. No, the bullet doesn't have acceleration. It just shoots out at the. Yeah, that's what kill me's for. Is the collision? Yeah, is the collision. So that's just to say that. That's to tell the laser management system that that's done. Yeah. And we still the same thing as the ship will have an explode time. So when it hits something, we'll have a timer. All right, FaZe. See you later. Yeah, the current rotation. You know, if you remember in the shape, the current rotation. In shape we have the rotation. Look. There, rotation. So that's our direction. Yeah, that's in shape already. So we don't need it in laser. I'm just looking. So X, Y. So what we need to do here is initialize everything. Yeah, initialize everything. So, oh. Yes, we're going to be passing in the speed. Going to be passing in the speed because the speed is dependent on how fast the ship is going. So if the ship's going quick, we need the bullets to come out quicker. Yeah. Right. So. So x point equals x. But I'm already doing that. I'm already doing that in shape, so I don't need to worry about that in shape. Same with R. So Vx equals Vx. Vy equals Vy. Distance travelled. We're going to reset 0. Kill me equals false. And explode time equals 0. So we're just resetting everything. You could put Vx and Vy in a separate class and use multiple inheritance. Yes, yes. Well, I have actually got that. It's in Vertex. Yeah, I've already got that in Vertex. But I'm trying to. I mean, I did explain multiple inheritance in the tutorials, but it's a concept that most beginners struggle with, and in inheritance in itself, in its simplest form, where we're just inheriting one class into the next, is still a concept that troubles beginners, and I just don't want to overcomplicate this at the moment. You and me were seasoned coders, you know, so we know all about this, but I'm trying to for the beginners. This is the whole point of this, is for the beginners, to try and get the noobs off into being able to do it themselves. Right, so what else do we need? So the draw itself will be handled by the shape class, because we're just doing a normal triangle. What we're not doing though, the limit number of bullets will actually be in the ship class, because the ship class is going to contain the array of the lasers. You've just got another coffee. Well done, mate. Well done. I miss coffee. I do miss coffee. Not allowed it anymore. Not allowed. Yeah. Yeah, you go for it, mate. Have one for me. I'm just wondering. No, I've got red flames, so we need to set the colour. We need to set the colour so the lasers can have a different colour. So what colour should we do? What colour should we do? Red, shouldn't we? So at the moment, the default colour is everything's on. So if we want red, then we'll turn green to be 0 and blue to be 0. So we have red lasers, yeah? Oh, green lasers, okay. Then we'll make that red. Green lasers. So we've got green lasers. So by default, the colours is white, yeah? So they're all set to 255. So if we set them to 0, that means we get green lasers. Right, so what do we need? We need an update. We need an update because the drawer is going to take care of drawing it, but we need an update so we can update the laser through its through its life cycle. So now what I've got here in Python, I'm going to do here. So here we go. So the first thing we do is if the distance travelled.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Oh, Nicomo, thank you very much for the bits. Thank you. That's some more treats for the two boys back there. Right, so if the distance travelled is greater than the laser distance, and I bet it's multiplied by the, yeah, here we go. So it's multiplied by the width. Whoops. Wrong place. Multiplied by the width of the screen. Oh, you're very kind, mate. You're very, very kind. Right, so if the distance travelled is greater than laser distance times by the width. So basically, this laser distance is a proportion of the screen width. So we're saying the laser will only survive for 40% of the screen width. Yep. So once that happens, we say kill me equals true. So that's then flagging that, right, the manager of the lasers can get rid of it, yeah? So that's that. Then we're doing, oh, the explode time. Right, if. So explode time is greater than 0. That means we are in the middle of an explosion. What are we doing there? So we're going to say explode time minus minus. So we're going to minus 1 off it. And then we're going to say if explode time is equal to 0. So if we've just minus 1 off it and it's now 0, we're going to say kill me equals true, because we've now finished with the explosion. Right. Oh, we've got an else in there. So if the explode time is 0, then we are doing x point plus equals Vx, and y point plus equals Vy. And they are not working because I forgot that. So if the explode time is 0, which means it's not exploding, that means it's still traveling. So we apply the velocity. We apply the velocity to. You can return when you set it to true, can't you? I don't know. Can you? So you can also delete else. I don't know. This is something I'm going to be finding out, because I'm going to be trying to use the queue to do it. So I don't know if you could delete from within yourself. How can you delete yourself? We'll see. We'll see. Right, so distance travelled plus equal, right, so what on earth? Okay. Oh! Is that true? Is that right? You can on a void function you can just put return and it returns back. Well, I never. You learn something new every day. So I can do this. Every day's a school day. Well, I never. I didn't think you could do that. Well, you learn something new every day. Learn something new every day. Right, so I'm looking for C++ square root. This one is too deep. Ah, right, okay. So I won't be able to return out that one. Okay. Oh, where's that? There we go. Square root of x. Right, okay. So that's saying that the SQRT, open bracket, close bracket, square root. Put it in 51. Oh, I see what you mean. I see what you mean. Okay. But I can't return there. I can't return there because I see where you're coming from, mate. I can see where you're coming from. Let me just do the rest of this and I'll see if the flow's right, yeah? I'll see if the flow's right. Because if I don't do anything afterwards on the kill me flag, then yeah. Right, square to power C++ to the power function. Here we go. So it's POW. All right, something to the power of 2. Okay. So it's POW and then something to the power of 2. So in my case, it's VX 2 plus POW VY2. It's amazing how Python and C++ have very similar commands. Right, then we've got the border checks. Now I can nick that from here. Right, where's the border checks? There they are. Really, I should make that a function, really, shouldn't I? Should make that a function. But the shape has no velocity against it. So what you're saying is to do VX like that. That's what you're saying, yeah? Yeah, I'm happy with that. I'm happy with that. Right, so right, so we have got the laser in there. Yes. Yes. I am including CMath. Oh, right. So how are we going to do this? You still need the return back where it was. So I do definitely need it there, don't I? That's what was making, if that's what you're saying, yeah? Because I was wondering. Yeah. When you said it was too deep, I was questioning it myself. Right, so that's the wraparound. So this is the update. Right, so that's the update. So now we need a way of activating this, yeah? So we need a way of activating, and so we'll put the key code in here. So we'll grab this and we'll put another case statement in there. So this time it's going to be space. And we're going to have a new function in here to do it. So let's get back into there. And I will put it, where should I put it? Yeah, we'll put it here. We'll put it here. So new ship. We'll put it here. Right, void. So I've called it shoot laser. I've called it shoot laser in Python. So that's what I'm going to call it here. So, right, so so this is our test, can we shoot? Yeah. So whoops. Oh, come on, John. I know what the problem is. Back is killing me now. And you've turned off again. Get back on. Right. Can I shoot? And that's a good question. Where's that URL? No, I don't want to do it in there. Cancel. I don't want to do it in there. Not in there. Not in the pie. Do it in there. Right. What methods have we got? Oh, size. Right, size. Returns the size of the queue. That's what we want. It's what we want. Right, so we're gonna... Right, let's activate the queue. So I've got laser. And I will need to include it, won't I? Come on, there we go. Right, so I need... Oh, I've imported queue. Why are you not working? Include queue. Queue. Why is that not liking that? Queue is not a template. What's it mean it's not a template? Oh, don't tell me this is gonna scupper me. I mean, there's no space. Q laser star. Well, this doesn't... Okay. It's still not liking it. I mean, it knows about it. Oh, whatever. Oh. Yeah. It would help if I was on the right one. Player 1313. Prime. There's not... Have I not finished off something? Yes, I have not finished off that. Let's just rem that out. Right. Come on. No. It's going sig... Is sig Q? Error. Q does not name a type. Did you mean sig Q? What's sig Q? You know, I look at this and it's... I look at this and it's just... Q class is a container adapter. Container is an object that holds data of the same type. Q can be created from different sequence container. Container adapter does not support iterators. Therefore, we cannot use them for data manipulation. How are they? They do support push and pull for data insertion and deletion. Yeah. I'm a little bit annoyed because try defining it in a method. Oh, yeah, but how do I make it global? How do I make it global? Because that's the whole point of this, isn't it? Why don't they give me an example? Give me an example! Did I use the namespace standard? No. Do I need to put that in, do I? What, hit somewhere here? Using namespace like that. Really? Really? So if I didn't do that, the thing that I'm missing then here is that. What a What's the matter, buddy? Aston, what's the matter? What's the matter? Come here. Ooh, I completely forgot about the namespace. Right, okay. Completely forgot about the namespace. Because I've been doing this all the time, look. Still, I don't think it's a good idea to put lasers and not a pointer in the queue. Right. Okay. Well, hang on. I think Aston needs to go out. Just bear me a second for it. You're going to see an old man get up now. I hate my back. Oh. Since laser only. I don't know. I mean, I was looking at the example, and I thought that it looked after itself. Yeah. So, whatever. Yeah, this is what I was looking at, but nothing suggested about doing pointers. So that's what I was going to try and replicate. Yeah. So let's go back to the. Once we get this this shoot done, then I'll have to call it a day. Laser star laser creates a laser on the heap. Right. This is like I say, this concept, this pointer concept is alien. I mean, that's why I've tried not to talk about pointers. Yeah. Yeah. Well, let's just see if this queue will work how I hope. So queue that dot size. So if that, oh my back, it's absolute going after Aston, nightmare. And that dot size. So if the size is less than or equal to what have I got it as? Laser max. I think I've got that. Laser max. Right, can we shoot, and have we got enough, have we got any spacers? That's basically what that means. The cue will work, but the laser will be removed when the crate... Is it? Alright, then you'll have to... Let me just do this and then you can... and then you can... Or we might have to wait because, I mean, it's pretty late. I mean, I'm not at work, so... I'm still on holiday. Right, so... The way I create the laser is the problem. All right, let's just do this, yeah. So we're going to create the start point of the laser, yeah. So laser X is equal to X point plus, and we're going to do 3/4 because that's at the top of the ship. Star radius. So 3/4 of the radius times by cosine of the rotation of the ship. So it's going to come out where it's coming out. So y is going to be the same as that. Y. The only difference is we are negative in it. Yeah, that's a concept that, I mean, sometimes I struggle with sometimes. Right, so that's the X and Y. So we need to determine the we need to determine the speeds. So velocity X is equal to laser speed, which is a constant that I copied up, times by, right, the cosine of the rotation. Ah, it's not rotation though, is it? It's not rotation. It is radians. That's the one I want. That's that. And then we divide it by the frames per second because that's the velocity, because we want it to move a specific amount in a frame. And we do the velocity y, which is the same, but this time it's the sine. Right. So we've got our start point. We've got the velocities. This is where Nikomo's saying that the problem is going to hit us in the face. So I was going to do laser, new laser, renderer, I think that's what I called it. Yeah, it's come back, right. Comma LX, comma LY, comma radius. Why have I got radius in there? I thought I took that out. I did. That does not need to be there. So then it's Vx and then Vy. So this is where you're saying I'm going to have an issue, because I was expecting that after I'd done that I would be doing this. I would be going Q laser dot push new laser. Like that. Yeah, and that would push that laser to the queue. But you're saying as soon as this shoot laser is finished, yeah, that new laser object disappears, and so the queue will not contain that object in there. Is that what you're saying? By the way, will I be able to see? Will I be able to go into the Q index and look at every element in its own right? Because I need to run through the queue to do the updates on all the lasers. Will I be able to see what every element in here just to read it? Because if that's the case, this is where the linked list works. So if I did Q laser bracket 0, I would see that one, yeah? We need to try it, don't we? Right, so in the player class, I need to run through the queue. I need to run through the queue. If it was overloaded, oh. See, in here I need to I need to run through. So I need to be able to do this. Let's see. I bet you this is not going to work. That's not going to work, is it? Because it doesn't know it's an array. I really didn't want to have to go down the linked list route. Oh dear. Gonna have to rethink this, I think. Vector. Right, okay. I'm gonna have to have a think about this. I'm gonna have to think about it because I'm trying to avoid pointers. I'm trying to avoid pointers, but looks like I'm not going to be able to do that. And trying to explain how pointers works. No, I know, can't avoid pointers. I know. I was trying my best not to have to. How would you delete? Well, I thought pop takes it off the queue, so it would remove it from the queue, and then we'd pop it off the queue. Tommy Cooper, just like that. Yeah, I'm gonna have to research pointers, aren't I? When I want to access, yeah, but yeah, well, that's why I've got the flag kill me, so we would pop it off the, you know, we'd pop it off the queue. That's why I was wanting to be able to look at the objects in the queue, but if we can't look at it, alright then. Right, it's midnight here, so I'm going to, I'll call it, I'm going to have to do some research on pointers. But yes, when you kill it, it has already gone. Yeah. Alright then, let me do some research on this vector pointer type thing. Or maybe we have to do a linked list. Alright then. Well, thank you very much for helping me out. I'm hoping my back will be better by Monday, because it is giving me grief. A linked list is not needed. Alright, I'll research this vector and then see if I can get it to work, and then I'll explain it. Take 2 paracetamol. Oh, Panadol, and call the doctor in the morning. Yeah, well, in the UK, mate, we've got a bit of an NHS crisis on the moment. I've took ibuprofen already, so I'll be taking paracetamol now before I go bed. Don't build linked lists yourself. Use the standard methods. All right then. I'll look at this vector, mate. I'll have a look at this vector. Yeah. All right. Well, guys, thank you very much for sticking with me, and we will continue this in the next stream, and then when people get bored, we'll get back to 6502. Hunchback is still there waiting. Alright then, I'm enjoying this. I like learning something new. Keeps the brain muscle working. Alright then, guys, take care, and I will see you next time. Alright? Bye! I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.